Okay, welcome to this very brief and short video about this project I have made called Visualization Artificial Intelligence. This video will last 15 minutes, and what I will do is that I'll present the most important takeaways from this work. So this project came to life in a way that we wanted to visualize artificial intelligence, and we wanted this AI to visualize different phenomena inside the world of physics. But what we found out during our work is that this is a rather complex situation and pretty hard to complete. So we modified our purpose to visualize artificial intelligence and its applications. So we wanted to see how AI are being visualized and how visualization of AI can help us both in the industry but also at schools and stuff and universities. So what we need to know first is that artificial intelligence broadly refers to human-like behavior displayed by any machine or system. And these AI systems are powered by algorithms using techniques such as machine learning and deep learning to demonstrate what we call intelligent behavior. So if we dive into the meaning of machine learning, we see that machine learning refers to the process by which the computer learns. So this could be pattern recognition or facial recognition, or also what you do on Netflix, and you watch a show and then you get recommended other shows that look similar to the show you just watched. That is called machine learning. So I build up 4 core steps to build this machine learning model. You first select and prepare a training data set necessary to solve the problem that you may wish to be solved. So let's say we wanted to create a facial recognition for all physics students at SDU. So this data can be labeled or unlabeled. So we could divide them or label them undergrads and grads, or students and professors and stuff like that. Then we choose an algorithm to run this training data. And if the data is labeled, the algorithm could be regression or decision trees or instant based. If the data is unlabeled, the algorithm could be a clustering algorithm or association algorithm or neural network. And the neural network is actually pretty exciting to see how it works, and we're going to discuss it in a few minutes. So when you have created your algorithm, you train the algorithm to create the model, and then when the model is complete, you use and improve the model. That is basically how machine learning works. But machine learning has also opened new gates for other computer learning strategies, such as deep learning. And this process uses a combination of multi-layer artificial neural networks. So in a way, to sum up, deep learning models are difficult to build as they use complex multi-layered neural networks, but they have the capability to learn themselves. Deep learning systems, they take more time to set up, but can generate results instantaneously, although the quality is likely to improve over time as more data becomes available. So let's look at an example, and an example could be this activation atlas. This activation atlas is built in a way that we wanted to resemble the human brain. And this activation atlas is available online. And what the folks behind this activation atlas wanted to do is that they wanted to resemble a human brain used for image recognition, and it works kind of the same way that our brain works. So we see a picture of a bike, we know it's a bike because it has 2 wheels and it has a steering wheel and a bell and a seat and a saddle and stuff like that. And we know it because we have some neurons that activates our compartments of defining what a bike is. And that's what they do as well here. So they have these individual neurons that are pictures of everything. Could be a raccoon, a snorkel, Darth Vader from Star Wars, and and a lot of different neurons. So Then they do these pairwise interactions of it and create layers, and then between the layers they create these spatial activations, and at last they will build this activation atlas. It should be said that it's not complete at all. As said before, the results should improve over time. But what it does compared to machine learning is that this evolves itself by continuously updating itself. It should be emphasized, though, that these atlases are not complete, as I just said, but because they can reveal high-level misunderstandings. So we see here a picture of a gray whale, and it says this atlas is 91% sure that this is a gray whale, and it's 7.5% sure it's a blue whale, and so much more. And when we include a picture of a baseball, it's not sure that it's a gray whale more. It says that it's a great white shark, and it then says it's a baseball, and third is a gray whale, and at fourth it says that this is a sombrero, like the hat the Mexicans wear. But I mean, so I think it's pretty obvious that there is a lot of room for improvement. So another aspect of AI is hyperspectral imaging and multispectral imaging. And hyperspectral imaging can be used in a lot of different ways. If we turn to how it could be used in the industry and the school as well, is that so multispectral imaging or hyperspectral imaging is the study of, you use artificial intelligence to do it, but what it essentially is that compared to when you're taking a picture on your phone, you let in all visible light and then you see the picture. But if you only let in a different wavelength of light, a certain wavelength of light, you would only see what it is at this wavelength of light. So when you create multispectral images, you combine all these layers just like you did for neural networks. Here is just images before it was neurons. So multispectral imaging and hyperspectral imaging reveals what one contribution can't show. So an example here is the stellar evolution around the nearby galaxy. And what we see here is an image of multispectral image. So here there are blue, red, and green blobs, and these blobs are stars. The blue is the green is present stars. The red is future stars, and I mean, it's the gas that we know will form into future stars, and the blue is previous stars. So what we see here is actually a timeline of the universe. I mean, it's not precisely a timeline, but it's quite hinting at one. So this is what multispectral imaging could be used for. It could also be used in the medicinal production of performing virtual biopsy, because biopsies are laborious and they are very time dependent. So if you could use it for a virtual biopsy, you will save yourself a lot of time and money and stuff like that. So I also had an interview with a machine engineer called Christian Darling at NewTek, and NewTek manufactures optical sorting machines for the type of potato that will work in the market and live up to the quality standards that the people want. So they sort potatoes. But what they do is that they use hyperspectral imaging. So they run these potatoes through a hyperspectral image that is also using this neural network that activates the machine when they see a potato that contains dirt or glass or a stone, and they sort them so they only have the good potatoes to eat. I mean, NewTek is kind of market leaning producers, so they heavily rely on the use of artificial intelligence and AI. So this is just an example. So if we turn to what artificial intelligence can do at schools, is that whenever I mention an equation to myself, like it could be Schrödinger's equation or it could be Newton's laws of motions, I always visualize some text written on a blackboard. But what if you could create an image that, without using these formulas, but shows some action that resembles these equations? That was the goal. It was a bit hard to do, but what we used is called an OpenAI, and it's called DALL-E, and it is a new AI system that can create realistic images and art from a description in natural language. So you give it a line of text, and it produces the image that you give. So what we see here is a line of text that I gave it, a photo of quantum dynamics, and this is the picture it resolves. It showed me. I mean, there's a lot of room for interpretation of this image, but what I think it shows is two somewhat nuclei that has protons and neutrons inside, and this could be electron proton fission or stuff like that we see in quantum dynamics. I mean, this is not a real photo, this is computer generated, and it is of course not in correspondence to what the certified equations say, but it's visualizing this phenomenon in physics. Another thing is the physics laboratory. I mean, we could see it gives a picture of what we interpret to be a physics laboratory. We see there's some kind of a watch and a table and a power generator and voltmeter, ampere meter, and some different kinds of physics apparatus. So I won't really go into detail in this video. This could be read in the report. But I also created images that that resembles other things. So I told it to image an astronaut launching on a McDonald's in space, and well, it really does. But what is the problem is that this face here is kind of brushed out. It doesn't resemble a real person, and I have a lot of points of view in my discussion here. But what I really think is the most important to mention before this video ends is that the people behind the very bright people behind this image recognition and AI, DALL-E here, censors the input. So you cannot write hate speech or violent images, or you cannot write slavery and stuff like that. And AI really is a product of our time and mankind's time here on Earth. But when you censor yourself to an input and you simultaneously say that this is real world, I would argue that it is not real world, because the real world contains both disadvantages, advantages, negative effects, positive effects. But when you censor your input like this, you set your own play of game. You set your own rules in the game, and if people want to play in your real world, they have to live with the blind eye. It's kind of dictatorship. So what it is, it's actually more of a machine of authority, and this is good, of course, because you prevent yourself from harmful generations and hate speech and stuff like that. But since AI is a product of our time and all the data that we find is available on the World Wide Web, we need to include these negative effects, and maybe, who knows, that we could make sure that these bad things, I mean wars and stuff like that, won't happen again. And at last, I want to sum up with this line of text here that I wrote. So although AI cannot solve all your organization's problems, it has the potential to completely change how business is done, that we have seen with new tech. It affects every sector, yes, the cosmology or other things, other studies like that. So it affects every sector from manufacturing to finance, and bringing about never before seen increases in efficiency. I mean, it doesn't require a salary, it's not hungry. I mean, it's better in some way. And as more industries adopt and start experimenting with this technology, newer applications will of course be invented. So AI will bring a change of even more widespread and sweeping than the introduction of computing devices. So it will change, and it already has done, the way that we transact and get diagnosed and perform surgeries and drive our cars. It is already changing industrial processes, medical imaging, and financial modeling and computer vision. So yeah, this is what this work is about. I hope you'll find it fun to read.